Is there alien life in our solar system? We may find out sooner than you think, and it just might be at the bottom of an alien ocean on an icy moon of Jupiter.
Welcome to your online coffee break, where we discuss bite-sized topics that inspire, educate, and entertain. Here's your host, a software innovator, award-winning marketer, and astronomy and space buff, Chuck Fields.
Hello, thanks for joining me today. In this episode, we're going to explore Europa, the icy moon of Jupiter, and the mission to get there. NASA is currently building the Europa Clipper spacecraft, which will begin its voyage to the Jovian Moon in 2024. Joining us today to discuss his new book about this mission is David W. Brown. David is an award-winning writer whose work appears frequently in the New York Times, Scientific American, and Smithsonian. He is an Antarctic expeditioner, an endurance runner, a former U.S. Army paratrooper, and a veteran of Afghanistan. David just released his latest book, The Mission, an amazing behind-the-scenes narrative of NASA's deep space mission to Jupiter's moon, Europa, where alien life just might exist in an ocean beneath the frozen surface.
Online coffee break.
David, thank you so much for joining us today. Really appreciate it.
Thank you very much for having me.
Oh, it is a pleasure. I am loving your book, The Mission. I think it's fantastic. About a third of the way through, so not quite all there yet. But I did want to ask you, the mission is about Europa. Now, some of our listeners know that Europa is a moon of Jupiter. Others might not. But can you tell us a little bit more about why Europa is so fascinating and why it's so important that we explore it?
Well, Europa is a moon of Jupiter. It's about the size of our moon. I guess the big difference between our moon and that moon is there's about 2 to 3 times more water on Europa than there is on planet Earth. And when I say water, I'm not talking about some weird, strange green goo technical definition of water, but I mean the same stuff is in our ocean, right? You could plunge a cup into the European Ocean, drink it, and though it would be incredibly unhealthy for you, your body would know what to do with it. Consequently, if there's anywhere in the solar system likely to have life beyond Earth, it's Europa, and conceivably complex life. I mean, it might be microbes, but it might be sea monsters.
That right there is just so incredible to think about. And I did want to, again, go back to your book, The Mission. I want to ask you about this amazing subtitle. It's not quite your standard subtitle. And I was just wondering if you could kind of describe what led you to such a unique subtitle. And if you wouldn't mind, could you recite the subtitle?
Well, there's no chance I can recite it. I have a copy of it right here.
You can cheat. You can cheat, yes.
There we go. So the story behind the subtitle, which I'll read in a moment, I'm stridently anti-subtitle. I did not want to have a subtitle for my book, but my publishers felt like it would be a good idea to have a subtitle to give readers some idea of the book that they were going to get. So I wanted 0. They wanted something like 8. And we compromised at 83. The subtitle is, and I will be reading it because I do not have this committed to memory. Sure. The title of the book is The Mission, or How a Disciple of Carl Sagan, an ex-motocross racer, a Texas Tea Party congressman, the world's worst typewriter saleswoman, California mountain people, and an anonymous NASA functionary went to war with Mars, survived an insurgency at Saturn, traded blows with Washington, and stole a ride on an Alabama moon rocket to send a space robot to Jupiter in search of the second Garden of Eden at the bottom of an alien ocean inside of an ice world called Europa. A true story. And there you go.
Folks, if that doesn't make you want to go get this book, I don't know what will, because that is just wonderful. I'm sure that was well received by your publisher, of course, right?
It was that was an interesting story. One of the problems they had with the subtitle is that it breaks just about every database, so they have to abbreviate it to a true story in the various publishers and bookstore databases.
Well, I love it. It's a great book, a great read. I do want to talk just about the Europa mission, Europa Clipper mission itself. I know it's easy to underestimate just how much time and effort goes into a deep space mission like this. Can you give us maybe just a brief synopsis of what the Europa Clipper mission looks like at this point?
So Europa Clipper just passed what's called its critical design review. That means it's about time for JPL, Jet Propulsion Laboratory, NASA's research and development facility in California. It's about time for them to start sparking blowtorches and building a spaceship. In terms of size, the Europa Clipper with its wingspan. So it has these enormous solar panels on it. It's about the size of a regulation basketball court. Wow. So it's an enormous spacecraft, and one of the most complex ever built. The spacecraft is set to launch at the end of 2024. It's got a 6-year cruise phase to Jupiter. The unique challenge of exploring Europa is what's called the Jovian radiation belt. So when you look at the night sky, you see Jupiter. It looks like just a white dot. It looks like another star, though not blinking. If you could see its magnetosphere, though, Jupiter would be the size of 3 full moons. So it would be enormous. The Jovian radiation belt or the Jovian magnetosphere is the largest continuous structure in the solar system, aside from the sun's sphere of influence. The conditions there are a lot like the immediate aftermath of a detonated thermonuclear bomb. It's enormously inhospitable to robotic spacecraft. So Europa Clipper was an inventive way of exploring Europa. If you would just go into Europa's orbit, you've got to survive this blistering radiation, and within 3 months you would probably die. Your spacecraft would just be radiation poisoned, and that would be that. So Europa Clipper does something kind of inventive. Rather than orbiting Europa, it orbits Jupiter, and it encounters Europa each time it circles that planet. So it'll fly by Europa, get a little strip of Europa, and then fly away. So it's dipping into the radiation and flying right out of it. The upshot is, do enough flybys of Europa through enough orbits of Jupiter, and you get a 360-degree view of Europa just as if you had been in orbit there. So it's a really inventive way of doing it. It's going to keep the spacecraft alive a whole lot longer. And the Europeans have a spacecraft that's going to be going to Ganymede right around the same time as Europa Clipper. And that means you're going to be able to have synergistic science. You're going to have 2, maybe 3 spacecraft in the Jovian system, because Juno is still there right now. You're going to have 2 or maybe 3 spacecraft doing science, and they can sort of correlate that science and get more of a holistic view of the Jovian system. So this is an exciting time for outer planets exploration, and it took a long time to get this far.
It is really amazing, and you just realize just how much planning goes into something like this. I think that's something I love about your book is you really dive into just this amazing variety of key figures. You interviewed several scientists, Robert Pappalardo, and I believe JPL engineer Carla Clark. How do you pick such an incredible list of these key figures and interview them? That's incredible.
It was so over 100 people were interviewed for the book, everywhere from graduate student to the administrator of NASA. So it took 7 years to write the book. So it was a long time and a lot of work. What was an interesting challenge when I was writing the book is this sort of history didn't exist before. So if I were going to write a book about, say, I don't know, a battalion in the American Revolution, I didn't have to learn the history of the British Crown in the New World, right? That heavy lifting is already done. But in the case of a book like this, that history didn't exist. So I couldn't just build on top of an awful lot of Europa exploration history. I sort of had to invent or had to research and build that story and then tell the story on top of that. So it was certainly a time-consuming and challenging effort. How did I choose the people? Well, I tried to focus on sort of key figures along the way in order to tell the story, because it's a long story, right? So it's a 20-year story, and each character sort of can hand off the baton to another character, and it allows you to get a much more inclusive view of how these missions come about. You get to see it from the point of view of a project scientist. You get to see it from the point of view of an engineer. You get to see it from the point of view of NASA headquarters. And what was interesting while I was researching, writing, doing interviews, and so on, very frequently, nobody knew what anybody else felt or how anybody else felt. Really? So you would have people saying, yeah, he really didn't like us. And then I would talk to that person and he would say, no, I loved him. This was my reasoning. And when I was writing the book, sort of the goal was to make sure everybody was the hero of their own story. Because one of the cool things about space exploration in general, I find, is that people really don't have cynical motivations. People really seem to be doing this because they want the answers to questions. In this case, they want the answer to the life question. They want the answer to why is Europa such a strange looking object? What made those cracks? What is the nature of the ice shell? And what is the nature of that ocean? So it was it was certainly an interesting challenge because there were so many people and so many interesting people. Ultimately, I just sort of had to sculpt the story into something that was sort of digestible by the reader. From the first draft of the manuscript through the published work, I think 40% of the book was cut away, sort of to keep a velocity for the reader.
I couldn't imagine. And one thing that, as you're talking about just the people that are involved, is I love the selfless quality that they have. I mean, some of these people are literally dedicating years, if not decades, of their life to this. And then some of them, I mean, might not even, I mean, for some of these space missions, they might not even be around for the results to come in. I hate to say it like that, but I mean, what was your impression as you're talking to people and just realizing just that sheer passion and dedication? Because like you said, they're more interested in getting that knowledge of life elsewhere in the universe and they put that ahead of their own interests. What do you think about that?
We all like immediate gratification, right? It's not enough to order something from Amazon. We want it delivered in like 1 or 2 days or same day now, right? The exploration of the outer planets of the solar system are not like that. It's not a game for the impatient.
Right.
One thing that I found was, so you become a scientist because you want to answer a question, right? You have a question about something and you want the answer to it. In the case of something like Europa, but it could be the ice giants, it could be the Saturnian system. You pick an object. Pluto is a good example.
Yeah.
You pick an object in the outer solar system, and you're talking about not just taking away the development and taking away, and we'll talk a little bit about that, but just talking about cruise phase, right? So the fastest object ever built at the time was the New Horizons spacecraft. It had something like 54,000 miles per hour or something. Okay. And it had to fly that fast for like 9.5 years before it got to Pluto. That's just the cruise phase. For something like Europa Clipper, the earliest notional exploration plans began in like 1996. I think that was the first internal JPL study. The first formal NASA study, I think, started in 1998. The ocean was sort of proven, or as close as you can get to being proven, in 2000. And at that point, it became very clear that this is a place we absolutely need to explore. But when we talk about these sorts of timelines, we talk about something that started in 1996, and in 96, like there had already been exploration, several years of exploration with the Galileo spacecraft. The point that I'm trying to get at here is you might have to spend your entire career not getting an answer to your question, but setting up the next generation to get the answer to that question. And that's not even launching the spacecraft. That's just getting the scientific community to agree this is a worthwhile endeavor. That's getting, and that's one of the challenges, getting what's called a new start at NASA, right? So you've got to get the scientific community on board, which is very hard because it's an infinite universe and every planetary scientist has their own thing. Like if you're a Venus scientist, well, you want to go to Venus. You don't want to go to Europa. If you're a Pluto scientist, why are we going back to Jupiter? We've got a spacecraft there. So you've got this push and pull. So the scientific community has to get on board. You've got to get NASA headquarters on board because NASA is a perennially underfunded agency. It gets 0.5% of the federal budget, which means, and of that, only 1/4 goes toward robotic planetary exploration. So what you're looking at is very little money, an entire universe to explore, and so if you're going to explore the solar system, for example, do you go somewhere that's relatively easy? And I use the word relatively, like
sure,
extremely large values of relative. Mm-hmm. Somewhere relatively easy like Mars, right? 9-month journey, one planet over, nothing to it. Or do you go to, the Jovian radiation belt, which is going to melt the brains of most robots? With limited amounts of funds, you're probably going to go with the sure thing. Astronauts are one day going to walk on Mars. Let's go to Mars. Yeah.
I learned from your book that the Mars 2020 mission actually almost canceled the plans to Europa. Can you share just briefly that story?
Right. So it's kind of an interesting, there's an interesting interrelationship between all of these missions. And that's one thing that I really tried to sort of a point I tried to drive home in the mission, that there's a direct connection from Europa Clipper to the Apollo program, to the Mercury program. I mean, all of this stuff is connected in very intricate ways. NASA is quite a remarkable engine. The planetary science community operates on consensus. They come together every 10 years and say, these are the top scientific questions that we need answered. And they call this the Decadal Survey. The previous Decadal Survey in 2003 endorsed a Europa mission as the top priority of the planetary science community. And that is the sort of the motive power behind getting this sort of mission going. Well, in 2013, it was announced in 2011, the Decadal came back and said the top priority of the planetary science community is Mars sample return. During all this time, the Europa team had finally developed a mission, finally gotten NASA headquarters on board, had a really refined plan, had a really elegant solution to a lot of problems. And as soon as the Decadal Survey said, no, let's go to Mars, that was the end of Jupiter Europa orbiter. Years of work vaporized overnight. The Mars mission that they endorsed, of course, would go on to become Mars 2020. It would become the Perseverance rover, which is the first half of a sample return mission sequence. So this one's going to sort of scoop up, well, not scoop up. It's going to get core samples, little tiny core samples of Mars. It's going to put them in little weird looking tube bottles, and it's going to leave them on the surface of Mars. And some future robot's going to come along, pick them up, and fire them into space. And maybe that mission will also fire them back to Earth, or maybe a third mission will actually collect that capsule in orbit and send it back to Earth. I don't know what the architecture is, because I think it's still sort of a moving target, no pun intended. But because we got Perseverance, we lost a Europa mission, and the only reason that it really made any progress beyond that was because a congressman from Texas, his name is John Culberson. He's no longer a member of Congress. Yeah. He's just a space nut. He just really likes this stuff, and he was a sharp guy. He knows planetary science, and he happened to be on the appropriations subcommittee that is responsible for NASA's funding, and so he put it into law, into the actual appropriations bill, that NASA will build a Europa mission. And he used to joke that Europa Clipper was the only mission that it was illegal for NASA not to fly.
That's true. David, I do want to say I'm impressed by your sort of explorer nature. You're an Antarctic expeditioner, endurance runner, former U.S. Army paratrooper, veteran of Afghanistan. Thank you so much for your service. Where did you get such a strong interest in space? Where'd that come from?
So that's a really good question. When I first started my writing career, or my journalism career rather, I covered politics and I covered foreign policy. And I don't need to explain to anybody that it's pretty depressing, right? Yeah. And after a couple of years of doing it, I would just wake up in the morning saying, I can't do this another day. I'm miserable all the time. I hate what I do. I hate the people I'm writing about, and I hate everything that they're doing. And I asked myself, what do I love, right? Because that's one of the cool things about being a writer, right? You can follow really sort of your interest. And I said, well, I love space and I love robots. So then I spent, the remainder of my career so far writing about space robots. It's been great.
I do have one last corny question. Would you go to space if you were given the opportunity?
Absolutely. I'd go tomorrow.
Do you have a preference? SpaceX, Blue Origin, Virgin Galactic, whoever?
Well, if any of them are watching, I will go for the first person who asks. So call me, guys. Like I'm ready. We need, you know what? I do believe this. I mentioned this on Twitter the other day, that I think we probably have enough engineers and Navy SEALs on the International Space Station, but what we do need are more poets, right? We do need more artists up there, people who can convey that sense of wonder and just the magnificence of the earth below and the stars above. I volunteer as tribute. I will take one for the team and just go ahead and go to space.
Maybe Yusaki is watching for the Dear Moon program.
Well, consider this my audition tape.
There you go. Dear Moon, I hope you get it. That would be awesome. We could also hashtag send David W. Brown to space. Something like that. It's probably
that may be the greatest hashtag in the history of social media.
It's trending now. David, again, I just want to thank you for this awesome book, and I want to thank you for taking time out of your busy schedule to join us today. We really appreciate it. It's been an honor.
Now, the pleasure is all mine. Thank you so much.
Online coffee break.
Well, I really enjoyed my conversation with David, and I'm excited about the upcoming mission to Europa. That's going to be incredible. If you'd like to find out more about David, just go to his website at DWB, that's for David W. Brown.io. So DWB.io. If you'd like to purchase his book, The Mission, it's available wherever you get your books. If you'd like to find out more about NASA's Europa Clipper mission, just go to europa.nasa.gov. I want to thank David for joining us today. I want to thank you for taking time to join us as well. Hope you enjoyed the episode. If you did, we'd love it if you'd smash that subscribe button or hit the like button. We appreciate that too. Thanks so much for taking time to join us. We'll see you next time. God bless.